Okay, guys, sorry I can't be there to go over this with you, but I think we're going to be okay. We're going to talk about electrical power. Now, you've dealt with electrical power anytime you've bought a light bulb, because the way you can tell how bright that light bulb is how many watts it's in. The more watts, the brighter the bulb is. Now, granted, certain bulbs are more efficient. They give you more light for the same number of watts, but what we're really talking about is how much energy the light bulb is going to be using per period of time. Power equals your work over time. So it's your work or energy divided by the time that it uses it in. Now let's think a little bit about energy. We learned in the last unit, static electricity, that if I take two parallel plates and I put a battery across those two parallel plates, positive, negative, makes this plate positive, this plate negative, and put a little charge in between there, let's make that charge positive, it's going to start to head over towards the other plate. And we could find out what the work's being done on it from your potential equals the work divided by the charge. Now let's rearrange that a little bit. Let's make it my work or energy is going to be the charge times the electrical potential. Let's divide both sides of this by time, because that's going to give us power on our left-hand side. Power is going to be Q V over T. Let's pull out the Q and the T together. And charge over time is current. So my power is going to turn out to be my current times the voltage that's applied across that particular part of the circuit. Now what's nice about this is that one equation actually gives us a bunch of different options using Ohm's law. What I mean by that is, well, you know that your power is your voltage times your current, your electrical potential times the current. And you know that, well, V is equal to IR. We've done Ohm's law. Let's take this, slip it in for V. That's going to give me current times my resistance times my current, or I squared R. Let's try a little differently. Power equals VI. And you also happen to know I can rearrange that. So I get I is equal to V over R. Let's take that and slip it right in there for the current. And that's going to give me V times V over R. Or that gives me V squared over R. So I put that all together, you get exactly what's right in your reference table. Power is going to be your current times your electric potential difference, which is going to be equal to your current squared times your resistance, or is going to be equal to your voltage squared divided by your resistance. And that's exactly the way it is on the reference table. Of course, as I mentioned before, power is going to be in watts. Sometimes I may ask about something and say you've got a 10-watt resistor. They're not telling you that it's the power that they're giving you. They're just telling you the number of watts, and they expect you to realize that it is power. Let's take an example here. Let's say I've got a nice simple circuit. Here's my circuit. I've got a 20 ohm resistor. That's going to be R1. And then I'm going to throw a new symbol in here for you. Nothing too crazy. It's just the symbol for a light bulb. It's going to act like a resistor. And we're going to call it R2. It's going to be a light bulb. And that's a 100-watt light bulb. Now, I'm going to place an ammeter right over here in the circuit. And that ammeter is going to read 2 amps. And here's what we want to find out. We want to find out what is the voltage at the source. Now, you're going to look at this and say, hold it, I got current here, I've got my power for that, and I got my resistance. Well, we're going to do what we always should do, and that's make a chart. Now, we're going to do exactly what we did in all our previous questions. R, V, I. But we're going to add an additional column for power. There we go. Now we've got two resistors, 1 and 2. I'm going to put a further column down there for total. And we're all set. Let's put in everything we know already. Resistor 1 is 20 ohms. I know nothing about the light bulb, which we're calling resistor 2, except it's got a power of 100 watts. And I know that there are 2 amps coming right out of that battery there, so that's going to be my total current. Of course, we're going to ask the magic question, which is, what is the same? And because there's no branching around this, this is a series circuit. And a series circuit, we know that the current is the same. I total equals I1 equals I2. So I'm going to put that right in here. 2 amps and 2 amps, since the current is the same all the way through. Now, I got a bunch of different ways I can find my electrical potential, but I think what I'm going to do is I'm going to find the voltage drop across each one of these 2 resistors. If I find those voltage drops, I can find out what my total voltage is because they add up in the series circuit. So let's do the first one. I got R, I, and I want to find V. Well, that's pretty easy. It's Ohm's law. V1 equals I1 times R1, which is going to be equal to 2 amps times 20 ohms, and that's going to give me 40 volts. So I know this guy is going to have a 40 volt drop across it, and I'm just going to draw in a little voltmeter right across there and mark that as 40 volts. Whoops. Cool. There's 40 volts on there. Now the next thing I'm going to do is I'm going to do the same thing for my light bulb. Problem is, I don't have resistance. I've got the power, but it's not that hard. I know P equals VI equals I squared R equals V squared over R. Oh, look. I got P and I've got my current. I can solve for the voltage pretty easily. P equals VI. I've got 100 watts equals my voltage times my current. My current's 2 amps because it's the same everywhere. So no, this is going to be 2s. I should put 2s there. And V2 is going to turn out to be, a little quick division, 50 volts. Cool. Let's put in a little meter across there. We put our voltmeter in. There's my voltmeter. Whoops. And that's going to be 50 volts. Now we take one look at that and we say, oh, hold it. I know that in a series circuit, voltages add up. My electric potential adds up. V total is equal to V1 plus V2. That's going to turn out to be 40 volts plus 50 volts. And that's going to turn out to be 90 volts. So that's 90 volts right across there for the total. And if I put a voltmeter across my battery, I'm going to go a little further out here so I don't go through my markings there. V, and that gives me 90 volts, and that's V total. This is V1, this is V2, and we're all set. One last quick thing. If you're asked about energy, it's actually a gift. Because remember, since your power is equal to your work or energy divided by your time, little cross multiplication, my energy is simply my power times my time. And I have a whole bunch of relationships I can put in there for power. I happen to know that power is my potential difference times my current times my time, because P equals VI. Or I could put in I squared R times T. I'm just substituting in the relationship we had before. or I can put it in here, v squared t over r. Most of this is right on your reference tables. As I said before, we simply substituted in the equations we had for power in what we worked out earlier into our energy equation. At this point, guys, you should be able to answer the vast majority of the questions that you're going to have to work on over the next couple days. All right? Hope this helped you out. If you want to rerun it, ask the sub to go back and rerun it for you. But I think you should be in good shape. All right? Take care, and I'll see you in a couple days. Bye-bye now.